But what we're going to work on right now is this Kinetics Workbook. So I want everybody to download and then open up this workbook. Okay, so I'm going to open it up here on my screen here, and then we'll kind of go from there. So I'm going to make sure I can see all you guys over here. So give me a thumbs up when you've successfully opened up this document. Okay, Connor's good. Emma, Kate. Lexi's good. Is that a thumb up? Thumbs up, Andrew? Okay. All right, thank you, Ashley. Bailey's good. All right, Corinne's good. All right, so I'm just going to walk you through. So this essentially is data from, I think, 3 years ago now. This was 2017. They probably had some of the best data I'd seen over the years, so I thought that this was just kind of a good set for us to use to understand how this process works. So last week, what you guys did is you guys took your data that was time and absorbance, right? And then you made plots where you fit them to a straight line, right? Hopefully everybody remembers that. The challenge that we had last week is I didn't do a good enough job determining where the breaks in each group's data was. And so trying to figure out like what experiment was that, it just got so messy. So I said, you know what, we're just gonna start with some data that I know exactly what it is. What this group did, and I kind of want to point this out. Let me make this bigger so that you guys can see the numbers here as I'm pointing to stuff. They actually did the conversion to concentration right at the beginning here. So remember, these are absorbance values. We really want to be plotting concentration as a function of time. So you can plot absorption as a function of time, and then when you get your slope, you just can change that to have units of concentration. Remember to do that. We've got Beer's law, right? Right? Don't have my iPad. That's Beer's law, right? So we've got absorption is equal to the extinction constant, or the extinction coefficient times the path length times concentration. So if I want to be able to directly relate the absorption that I get from the spectrophotometer to concentration, path length is always 1, so this is basically not anything we ever need to worry about. But if I actually know what this number is, I can actually calculate my concentration by taking my absorbance value and dividing it by the extinction coefficient. Everybody good with that algebra? All right, so I told you what the extinction coefficient was for this. I think I even have it written someplace here. Oh, I thought I had it written there. It's like 5,200 or something like that. So what this first group did is they actually converted each individual absorbance value to concentration. And because you can have Excel do all the calculations, it's really easy. So then when they made these plots, they actually plotted concentration as a function of time, right? They got their slope for this line, and that slope represents the rate of the reaction with units of micromole per second. Give me a thumbs up if everybody's with me. Okay, so you guys did that last week. And then what we went to do, which is where we got kind of stuck a little bit, or I didn't get as stuck with you guys. I told you we got stuck, and so we said we were just going to revisit this later, is we took those slopes and we put them into this right here. So I'm going to zoom this in so you can see this. So essentially, we took the slopes from each of those lines and we put them in here. Everybody with me? So if you want, go ahead and open up the initial velocity plots tab on this workbook. Because what we're going to do is we're going to move forward and do the kinetics analysis like this was our data from last week, and this is kind of where we started off. All right, so give me a thumbs up when everybody's got this sheet available. All right, very good. So one of the first things that we do when we do this kinetics analysis and we do it all together is we look at the data and we say, does everything seem to be making sense here, right? And we look at data in a vertical column, which represents, hey, do we see the trend we'd expect to see as we increase the concentration of substrate? Yeah, we do. The reaction gets faster, right? Do we see when we add inhibitor that it still shows that same trend, but maybe doesn't get as high? And we see that trend, right? So the data is trending like we'd expect. And then what we also do is we look horizontally, because we did this experiment in triplicate. These numbers should look fairly similar to one another. And so what I have shown in yellow here are data points that seem to be anomalous, right? They don't seem to fit the trend of their other two partners, right? So especially when you do things in triplicate, even more so if you were to do things by repeating an experiment for a total of 4 times, you have good justifiable reason to eliminate a data point, okay? So what we're going to do here is we analyze this data, is we are going to eliminate these data points as we figure our average and our standard deviation. So we're going to kind of move forward and do this data analysis. So the first thing we're going to do here is figure out the average of this data, right? So to figure out average, I'm going to do equals average, and then I'm going to do B3 to D3. So there's a couple ways you can do that. Again, you can hold down the shift key and select that range of data. You can put B3 with a colon and then write D3. There's lots of ways that you can do that, but I'm going to calculate that average, and then I'm going to drag this down to calculate the average for all of those. Okay? I'm going to copy and paste this, and I'm going to do this just for all of these, and we'll go back and we'll reconcile the ones that we don't feel are all that great. Okay, so now I've calculated the averages, because that's really what we want to plot. We're not going to plot individual trial data. We're going to plot the average of those trials, and we're going to calculate the standard deviation in just a second, and that standard deviation will be used for our error bars. So let's go ahead and fix this guy. Now, one of the things I want to show you is if you're selecting a cell here and I come up to where this is and I click anywhere in this equation box, it shows me the data points that are part of this. So there's a couple of ways I can fix that. I can just take and drag this bar. That's one way I can change the data that I'm going to have be part of that. So I want to exclude that one that we've highlighted in yellow. So I'll do that for that guy. This guy, I can't really, it's got 2 data points that are kind of distant from one another. So one of the ways that you can fix that, notice that this is a colon that's up here. If I take and I make that a comma, then that chooses just those individual cells. So that's another way to do that. Third way I want to show you how to do that. Let's imagine we want this guy and we want to say equals average. And if I want, I can pick one cell, and this is a Mac thing, so I don't know what the corresponding keystroke might be on a PC, but if I choose the command key, that would allow me to choose an adjacent cell that's maybe not immediately next to it. So I could have chosen a cell way out here the same way, but notice too, it puts a comma in there. So that allows me to average individual cells rather than a range of cells. Okay? Next thing I want to do is under standard deviation, I want to calculate the standard deviation. Over the past 2 years, I've realized that there's all kinds of different standard deviations you can use. The standard deviation .p is actually the best one to use, But because all of my numbers from previous years when we did this in 2017 were based on using just the standard deviation, I'm going to do that so that we don't get, I don't get different numbers that I don't know if they're right. So we're going to do STDEV, and we're just doing this standard deviation there, STDEV. So I'm going to select that, and I'm going to say I want it to be for this range of data. So for those 3 trials, tell me how much those data points deviate from one another. So then you can hit return and you will get an answer for that. So really what this means is that for my standard lactate dehydrogenase, when I used 5 millimolar lactate, the reaction velocity was 0.216 micromolar per second plus or minus 0.0258. Okay, that's what that means. So I'm going to do the same thing I did above with the average. I'm going to copy this calculation. I'm going to go ahead and fix it. Hi, CJ. I'm going to fix it for any of the, what do you need? He's deaf, so he doesn't know I'm talking to him. But I think he appreciates that I'm giving him some attention. What you need, honey? Yeah, sorry. All right, so I got to go and fix these guys. So I'm going to go and kind of fix these guys.
Dr. Perenni, I have a quick question.
Yeah.
So I'm on the data set 2 for the averages. How do you copy and paste it so it's like the same formula down?
So let's see. So you can just do like a Command C and then a Command V. You can paste that. Or if you want, do you see how my cursor turns from here? It's an open plus sign, and when it's a closed plus sign, I can drag and pull that down, and that means it copies that formula. Does that answer your question?
Yeah, I have it for the first set, but I don't know. You kind of went a little too fast and I got like stuck.
That's okay. So if I want to make, so I can just do a Command C, and then I come down here and I just do a Command V again, and it copies that same formula. And then when I got, so again, if I went down and I did it like this, and I just dragged it down, for this guy right here, I don't want that data point to be there. So if I come up here and I select where my formula is, there's a couple ways I can fix it. I can take and I can drag in the range of cells that are part of it. So that's how I can fix that one. Let me make sure that this guy is fixed here. Yep, that guy's good. For this guy, again, to select cells that are just not the same one, I could put a comma in there. So that'll allow me to fix that guy. And again, I'm going to fix this guy by, oh, that guy I already fixed that guy. But I think I need to fix this guy. Yes. Other questions that anybody has? That one works. Give me a thumbs up when
I
you're
have a
done.
question.
Yes, Andrew.
So, if we were doing this like for something real, like we're going to try to get this data published, can we just omit that data that we did?
Here's what we do. If we were to do that, like I would not publish data that we did this. I might still analyze this data and see what it tells me, but then I would repeat the whole experiment again and then see where I land. And that time maybe I would say I'm going to do 4 trials just to be certain. Connor.
So for the third data set, I did
Yep.
the standard deviation,
Mm-hmm.
just C21 and D21, and I'm not getting that same number you got.
Well, let's make sure I picked the right things. Nope, because I picked the wrong ones. I had B and D. There we go.
Okay.
Thanks for pointing that out, because that would have given us different results there. Yep. Any other questions? All right, I'm going to make this a little bit smaller here so I've got some room. What we're going to do now is we're going to plot this data. So if you want to watch for a second first, I'm going to kind of go through how to do it. Okay. We want to plot, and I think how Excel works is any column of data that's kind of on the left-hand side, it's assuming you want to be your X, and anything that's on the right, you want to be your Y. So, and we're not going to plot because we didn't, remember, we only did one trial of this anyways, or we were supposed to just do one trial when we had no lactate. That was just kind of a control to make sure nothing was going on. So I'm going to use these 5 concentrations. So I'm going to select these 5 concentrations, and then I can choose command, and then I can select over here, and that'll let me select 2 different sets or 2 different columns of data. If I tried to hold down the shift key, it would select everything in between. Okay, but what I'm going to do now is I've selected those. I'm going to come up to insert, and I want to do a, this time we're not going to fit this data to a straight line, so I'm going to do a scatter plot, but I'm going to do a smooth marked scatter plot. So I'm going to select that, and then I get this guy here. So if you guys want to take a moment, go ahead and do that. I'm going to kind of come back where I can see you guys here. And then give me a thumbs up when you get this first part. Now your colors might look different. You know, my defaults are set up to look a certain way, but you still should get a line that looks like that.
Dr. Parente,
Yes.
can you go over that one more time?
Yep. So I'm going to just delete this so we can see what I did. All right. So I'm going to select my concentrations of LDH. I'm going to hold down my command key. This is a Mac. I don't know what it might be on a PC. If someone is a PC and they know, kind of like let me know or let us know. But I'm going to hold down, because if I just held down the shift key and I went over here, it's going to select all of that. So, because I only want this column of data, I'm going to hold down my command key, and then I'm going to select this data. And then I'm going to come over to insert, and I'm going to do a smooth marked scatter plot. Okay, so then I get this guy. All right, so I'm going to look in look at your faces here. Give me a thumbs up if you've got this plot. I just want to make sure I don't move on before everybody's ready.
Dr. Perney, which one did you highlight first, the purple box or the blue box? I'm sorry.
Oh, that's a good question. I highlighted the purple one first, but let me see if it matters. I don't think it matters, but I'm curious to see if it does. So let me go and highlight this one first, and then this one, and then see if that matters. Nope, that doesn't matter. I think Excel makes the assumption that you have your X data left of your right data.
Dr. Parente,
Yes.
I have 2 lines on my chart. I have a series 1 and a series 2.
Do you want to share your screen for a minute? See if you can share your screen. Let me stop sharing mine.
I also have that too.
Bailey, are you nodding your head yes because you have that as well? All right, so.
Oh, I don't know where it went. It's right here.
Yes. So, all right. Click, so the chart is selected. So see up in the toolbar up above, it says select data. Click on that. I want to see what that says there.
Select data right here.
Yep. Okay. So try unclicking series 2. I mean, that'll make it right, but I don't know why it selected that in the first place.
So hit OK.
Yep, hit OK. Oh, I see what's going on here. Do you see how your x-axis just basically has 1, 2, 3, 4, 5, 6? I
Yeah.
think what you selected, go back and show me like the, well, let's go from, I think, did you select from where it said data set all the way down to 95, or did you just select from 5 down to 95?
I did that.
You see, and I think part of the issue is it sees text in trial 1 in that where it says negligible. So let's try this. Go ahead and try selecting your chart again, and I want to see if it shows us the data that you used.
So click on this.
See, sometimes it'll like highlight, like when you have an equation, it'll show you the stuff that you use. So let's start over. Press delete, and this might help the rest of you who are working on this. Go ahead and yeah, just delete both of those. So come back over and select now from just 5 to 95. And then go over and do the average. Now, I'm concerned a little bit because those numbers look weird with your averages.
It's just that's B3 to D3.
Huh, but why is it negative? Oh, do you see how you have a negative in front of the average? Do you see in
Yeah.
your equation? So just get rid of that negative. There you go. Now drag that down. Now, you're going to need to go and fix, oh, I guess the rest of them are okay. They don't have the negative. All right. So start with the number 5 and then drag down to 95 and then go over, yep, perfect. And now go to insert, chart, yep, there you go.
Much better.
Yeah.
Thank
So
you.
I think the problem is if you select stuff that has text as part of it, it's going to look at it and it's going to like count your each data point as belonging to kind of like this is data point 1, this is data point 2, and that becomes your x-axis. Oh, jeepers. Sorry. My sister-in-law tested positive for COVID. I think I told you guys that on Saturday. And so now the whole family has had to get tested. And my brother, his that's his wife, he was negative. Their older son was negative, but now their younger son is positive. So they're trying to figure out like why the other two. So sorry, just saw that message come in just saying all capital letters, Will is positive. And I'm like, oh my gosh. All right. So let me go back to sharing my screen. All right, so I think, is everybody good? Bailey, that might have fixed your problem too. Everybody's good? Has this plot? All right. So now what we want to do is we want to have essentially, we do want to have 3 data series, but not the way it was plotting it when you guys were doing stuff before. So what we need to do now is we need to add some data to this chart. So you probably can do this by kind of right-clicking on your chart. I think it's like control. It's going to be a control click on your chart that you can do select data here, or it's up here as well. So there's a couple places that you can get there, but I want to get to a place where we see this. We want to select the data source. So before I go on, I want to just make sure I wait until, give me a thumbs up when everybody gets to the select data source.
How did you do that again? I'm so sorry. I hate Excel.
That's all right. So a couple ways you can do it. Under the chart design, there should be this select data option. Or if you, and I think I don't know what it would be for a PC, but like you can, I can control click on the chart and I can get a bunch of options up here where there's a select data option.
PC, it's just right click.
It's just a right click? Okay. All right, did that get you there, Ashley?
Not yet. My computer's being a little slow.
All right. How about Emma? I did not see, I may have just missed you. You got a thumbs up? Okay.
Is it okay if I share my screen? Just
Yeah.
Okay.
Hang on, let me stop sharing mine.
Okay, I just don't want to get so far behind and then like. Can you see that?
It's starting to share. There we go. Okay.
Is that what it's supposed to look like? I'm not sure.
So let's see. Yes.
Yes.
Yeah. Yep.
Okay.
Yep. So it looks a little different than mine. What you're ultimately going to do in just a second is where that add button is. So why don't you stop sharing and I'm going to go back to mine.
I think that's like what a PC has, because mine has like the same thing as yours actually.
Got it. All right. So again, we're going to, we want to add 2 more sets of data. But the first thing I want to do is I'm going to label this first data series. I don't want it to just be nondescript as series 1. So under here, under a name, I'm going to say that this is my standard LDH. Okay, nothing special going on. Now I don't want to hit OK right now because then it'll get rid of this box. So I'm going to come immediately over to the plus sign. Those of you who are PC, it'll like I think it says that, you know, add data series or something. But we want to be able to add a second data series, and I'm going to call this one low inhibitor. Now if I hit tab, it's going to say, okay, what do you want your X values to be? I'm going to come over to my chart and I'm going to say, here they are, those concentrations again. Hit a tab again. What's your Y values? I'm going to come over here. It's this average velocity data. And I'm going to do that one more time because I want to do it for the high inhibitor data. So I'm going to again say plus. I'm going to call this guy high inhibitor. My X's are going to be right here. I'm not choosing the 0 data point. And then my Y's are here. And then your plot should look like what I've got shown here. So I'll give you guys a couple minutes to work on that. Give me a thumbs up when you're good with that.
For the standard LDH, which ones did you put for the X and Y again?
So that was our first data set that we just did. So you're always going to want to choose from 5 to 95. So we're only going to have 5 data points that we'll have, 5 to 95, and then we choose our average. That's what we're plotting. Our concentration, which is the 5 to 95, and then the average reaction velocity, which is these numbers here.
Okay, thank you.
Mm-hmm. So I think I saw a thumb. Show me a thumbs up. Andrew got a thumbs up. Bailey, Corinne. All right. Lexi's got a thumbs up. All right. Everybody good? Ashley, are you good? No.
What's going on with my laptop?
Do you want to share your screen again? Maybe we can help.
Yeah, I don't know what's going on. Hold on one second. Okay, can you see?
Yep. Yep.
Should I move this out of the way? Probably this table. Chart, if you'll let me.
So do me a favor. Just go ahead. Just cancel that right now because I want to make sure.
Okay.
And then just cancel that. We'll move your plot out of the way. so that we can, yeah, see stuff. And it's okay if it kind of bridges that break in the...
Okay.
Okay, so, yep, if you want here, hit the edit button right now, and we're going to edit series 1. So call this standard LDH. Yep. So say okay. Now go to add, and now call this low inhibitor. And hit tab when you're done. And now go and select in that, yep, but don't select the 0, go to 5. So select the 5 down to the 95. There you go. And now hit tab again. And now select the average. Yes. There you go. Yep. And now do high inhibitor. I like being able to see how it works on a PC, because some people will ask me how to do it on a PC, and I'm like, I don't know, I don't have a PC. All right, so now, yeah, and I can even see your plot on the right. It's updated with all that stuff, so you're all good. All right, so I'm going to share my screen again here. So I think everybody now has a plot that looks like this, right? So the other thing that we're going to do, well, first let me ask you guys a question. Does this data make sense? Does it look like we'd expect? Anybody have any thoughts? Kate's saying yes, so I'm going to put you on the spot. You had the biggest head nod.
I would say yeah, it looks pretty good because your blue line, that's when you have no inhibitor, so you would expect that to have the greatest reaction rate and probably reach its Vmax quickest.
Yep.
And then as you add inhibitor, you're slowing down your reaction rates.
Yep. And that red one is the low inhibitor, and then the green one is the high inhibitor. So that's consistent with that. I just want to show you a couple of other things we could do here. Not anything you have to do, but just so you kind of know. You can come over here to add a chart element. We can add a legend. And we can say, all right, why don't we put the legend at the bottom? Right? And here it's going to indicate whatever you called those data series, it's going to put that legend in so you can see what's going on. Same thing here if you wanted to add axes titles. So you could kind of put that in here. You'd have to say what this is, you know, but you could say that this was lactate concentration in millimolar, right? So all kinds of things that you can add in. You're going to access most of them by over here. So again, if we do axis titles, if we do a vertical one here, this is going to be our initial velocity. So again, not stuff that you have to do here. It's more that we're going to be actually getting information off of here. You can also kind of, you know, change the size of the chart so it kind of looks more reasonable. The last thing that we're going to do here is we want to add error bars. So I want to make sure to show you how to do error bars. Unfortunately, it seems like error bars are the biggest pain in the butt to do. How to add an error bar is you can select, don't select the whole chart because then it just gets really messy. We're going to do this one at a time. Select one data point within a data series, and then under the chart element, you're going to go to error bars. Now, I don't know why it doesn't allow me to kind of get to the thing right away where it's like I can customize these. So the first thing we're just going to do is it's going to say, hey, standard ones, and it's just a hot mess here, but we want to select the horizontal ones and press delete. And I got to move you guys out of the way here. If I select and I double click on these other ones, I'm going to get an option to format my error bars. And so what I want to do, I'm going to have to move you guys around here. I think this will be a good spot. I'm going to say custom, and I want to specify my value. Right now it's just saying, hey, plus or minus 1, does that sound good for an error bar? And you're like, no, I'm going to use my standard deviation. So I selected this first plot, this first data point here, this first plot, the blue plot, which is my standard LDH. So my positive error, I'm going to have it be my standard deviation for those. I'm just going to copy and then paste that here because I want my plus error bar and my minus error bar to be my standard deviation. So then I'm going to say OK. And then you should get something that looks like that. Okay. Once you get that, go ahead and do it with the second and the third data series as well. So again, you're going to select that, add element. I wonder, I'm going to try something here. I wonder if I come over here, does it give me, no, that's not what, it's not going to do it. I need to add error bars, and I'm going to have to do that whole thing again where I need to delete these guys, and then I'm left with making these custom. So I'm going to finish this up here, and then if you guys have questions, I can kind of help you out. So give me a thumbs up when you're, if you've gotten to this point, let me know.
How do I add points on my chart? It's just a solid line.
Oh, you don't have markers. All right, so let's see. So I think if you select, are you a Mac or a PC?
Mac.
Okay, so I think if you select a series, do you have this option over here with format data series?
Yes.
Okay, if you go to the paint bucket and then click on marker, I think under marker options, it might be selected as none.
I have 0 transparency as a color.
Oh, well, no, that should be fine.
Because it says solid line.
Well, so are you looking at line or marker here?
Marker.
So you're looking at marker.
Okay, there it is. It brought up border. Okay.
Yeah, so there's marker options, whether it's automatic and yeah.
Yep, got it. Thank you.
You're welcome. Anybody else questions on?
Do you know why mine keeps putting on like vertical and horizontal? Like it's putting like 2 error bars?
And I spent, and I only let myself spend about 15 minutes getting lost in Google on this, but I was like, why does it do both? And that's what
I can't get it to go away.
Nope. And it was this thing that people kept saying, I don't understand why, because in general, right, when you think about experimental data, right, or think about like measured versus manipulated variables, like your measured variable is the one that you're likely to have error bars on because that's the one you're measuring, not your manipulated one. So I do not get why, maybe because Excel wasn't made by an experimentalist, I don't know, but you'd think, and there's not even a way to go and like select, like I only want one or the other. I do feel like there used to be something in older versions of Excel, but each time Excel doesn't update, I feel like I need to relearn a little bit. And yeah, the only way that it says to be able to get rid of them is to manually select them. So once it puts both on, you can select either all the horizontal or all the vertical ones and then delete them. And just as a little tip and a trick, if they're so teeny tiny that you feel like you can't delete them, go in, and if there's a way to make them be like plus or minus 2 or some really large number, then you can make them large so that you can actually select them.
Good idea. Maybe I'll do that and then like redo the specify value thing.
Got it. Got it.
Yeah. Some of mine like aren't even showing vertical ones though. They're just showing horizontal. So I don't know what's up with that part.
Well,
Maybe it'll fix it.
Maybe, but it could be like, it could be that they're just so small. So when I kind of zoom in here, like some of the data was so small, or some of the standard deviations might be smaller than your marker size.
Okay.
So, and that's not a bad thing.
Okay, good.
All right, how's everybody else doing? So I don't remember. Give me a thumbs up if you're done. I think a lot of people are still working, but okay. So I think we've got Bailey and Corinne and Kate maybe still putting some final touches on.
What did you put for the X and Y axes titles?
Like, how did I get those?
Yeah.
So if you just select your chart, and then under the chart elements, there's an option to do axes titles. So once you select this, then it'll put a text box there, and then you double click on the text box and you can type in whatever you want.
Okay.
Raise your hand if you need some more time. Okay. Ashley, I'm seeing your prompt in the chat here. I don't know if that's recent. You just said, did you hear my question? You're super quiet. Like, I feel like I have to get like insanely close to my speaker here. Your computer is fighting with you. Especially since it's like, I'm not even going to let you talk to the teacher right now. Well, I can sort of hear you, but it's really hard. So I heard you say that you tried to undo something and like you can't get at anything. Your chart's not there anymore. Well, maybe the good news is you know how to make it again. Well, so here's the good news. Because we record all of this stuff, if you need to, because what I want to do is, especially if Kate's getting close to being done right now, I want to move on to the next piece. The next piece doesn't build on this one, so it's not like you needed to have this piece done to do the next one. So let's go on and do the next one. And even if it's something that you need to kind of spend a few minutes going back and redoing that one, you should have everything else kind of good. But so I think everybody, are you set, Kate? Okay, so we talked about when we did kinetics analysis, and we talked about kinetics in class, like this plot makes sense. We're going to make the reaction go faster as we increase the concentration of substrate, and as we add more inhibitor, it should get slower. But beyond that, this graph doesn't give us anything useful, because the two useful kinetics parameters are Km and Vmax. And we can't get Vmax, because remember, Vmax is when this blue line stops rising, right? That's Vmax. And then Km is 1/2 of that value. Well, if we can't figure out what that value is, we can't figure out what 1/2 of that value is. So we need to have some other way of analyzing this data, okay? So that takes us to the Lineweaver-Burke analysis. So just as a preview before we flip the page here, right now we're plotting initial velocity as a function of substrate concentration. What we're going to do on the next page is we're going to plot a double reciprocal. So 1 over this and then 1 over this. Okay? So and this is why, Ashley, you didn't need to worry, because we've already kind of done all the work on this. So if you flip to the next page over, which says Lineweaver-Burke analysis, it basically has all of this same data that we just did, okay? But then what I did is I took 1 over that data. So if you actually look in the equations here, you can see that this is 1 over B3. This is 1 over A3. And we got into the mathematical weeds like a couple years ago on this, and I'm not going to go into it with you, but other than to say I had some math-minded people who said, you can't just take 1 over the average. What you actually need to do is take 1 over each individual trial and then average that. And they said it has to do with order of operations for things. And I was like, okay. And we actually went through and we did it both ways and we got different numbers. So I was like, all right, that's fine. So this is why we actually take 1 over each individual piece of data. And then we go ahead and we do the average of that data and then the standard deviation. We're going to do the same thing with any data points that we thought were a bit anomalous, which we've highlighted in yellow here, that when we do our average and our standard deviation, we're not going to include those data points. So everybody with me with kind of like, all right, this is just the same data, but it's reciprocal, 1 over that data. Okay, so what we're going to do now is we're going to plot the same data. I'm going to plot this as my substrate concentration, but now it's going to be 1 over substrate concentration versus this. Okay, now this time just do a scatter plot with it. Don't do a don't connect the line. Okay, so you're going to do the same thing that we just did, and we're going to do it for all 3 data series. Okay, and I'm going to just be quiet for a little bit, let you guys do it too, and we'll
Wait, are we making a separate graph for each 3, or are we putting them on top of each other like we did?
exactly like you just did. So and just make sure to choose a scatter plot this time.
And you said this new data doesn't have the highlighted included?
Correct. I've already, when we did the averages and the standard deviations, we excluded those data points. So if you want, go ahead too, and you can put your error bars in. And then I'll wait till everybody gets to the point where our stuff looks the same here. So I'm opening up the participants window here. So I'm gonna use this as a way to kind of have you guys let me know when you're done or not with something. So you can use the participants window, give me a green check mark when you are finished and gotten to a plot that looks like my plot here. I'm gonna go ahead and add a couple of things.
Dr. Parente,
Yeah.
I keep trying to add error bars to this chart and now it's not giving me any.
Okay.
The one, like, it looks like I have one and it's really tiny and does not match yours.
Okay. Why don't you share your screen and I'll take a look.
The exact same thing happened to me. I don't know if it's what happened to her too, but I just assumed that the first one was standard when really it's the high inhibitor. So I was doing the wrong data.
So make sure that line that's the biggest line, like the steepest slope, that's actually your high inhibitor data. That's your slowest data.
Oh.
So that might be part of the issue. But
I think it is because when I like zoom in on this, I have like no error bars right here.
So yeah. So
I
what
think that's what I did.
So go ahead, select that data point. I want to see something here. Select that data point. And what happens if you go over, see where there's those little, like we've got the pentagon that's there, and then right next to it is the bars in the format data series. Okay. Go over to the left where we've got add chart element. Click on that. And then under error bars, when that pops up, say none. And now try going in and add error bars.
So I use these ones down here since the biggest one's the high one.
Correct. Yep. So that was right.
I had to add a chart legend to help me keep track of which one was which. Sometimes that's helpful.
Yes.
Okay.
So yeah, so double click on that. Yeah. Custom.
Oh, much better.
Yep. So was that what you were doing before? What were you doing before?
I was using this one.
Yep. And that's easy to do. I would tell you about half of the people this morning did the same thing.
Okay.
All right, how's everybody else doing? I see Andrew's got a green check mark, so he's done. Remember, use that as a way to tell me if you're done. So if you're done, give me a green check mark over in the participants window. Thank you.
You want to share your screen again, just so I can see if I had the right one. Okay, thank you.
Yep. So I'm going to keep it on here, just so that when we're all set, we'll go on to the next. If you'll excuse me for a second, I got to call my husband to find out who's picking up the kids from school. He should be, but he needs to have this little piece of paper.
Your call has been forwarded.
Dr. Parente, do we need to add access titles?
No, I just had time and I was doing it. For right now, you don't. I just kind of wanted to show you how to do it if you needed to do it. Are you going to be able to pick up the boys at 3:30 question mark? I forgot to give you that piece of orange paper that you need in order to pick them up, period. Are you going to be able to stop at home and grab it, question mark? All right, how you doing, Connor?
I was gonna add the axes, but I can do it later.
Yeah, and again, that you don't need to do that. All right, so the next step is this is something, the reason we plotted this just as a scatter plot is we are going to fit these data to a linear regression, and that line is going to be important for us, and we're going to talk about why in a second. So I want to make sure to show you, we've done this already, but if you select one of the data series here, and then I come back over, I have to kind of be in this chart design area, add a chart element. I need to move everybody out of the way here. We're going to add a trend line. And I'm going to do a linear trend line. Now, what I need to do is when I click on this, I double click on it and it'll pull up this format option again. Now I'm going to format my trend line. I need to display the equation and the r squared value. Okay. When we can have a straight line, we can get useful information from the slope and the y-intercepts. We're going to talk about that here. So if you want, go ahead and do that for your other data series. Where'd my plot go? Now my plot, oh, there it is. I'm like, my plot disappeared too. I think it doesn't like being so small. So again, just give me that green check mark in our participants window here when you've gotten everything put on your chart. All right, everybody's done. So I'm going to go to another document here for a second. Too much on the screen here, so let's minimize this. All right. So this is a document that's available if you wanted to look at it. It's on Blackboard, so it's the data analysis piece. So I'm just going to kind of go real quickly through the stuff that we've already done, right? So we plotted concentration versus time. We got the slope of that, and that is our initial velocity, right? So that's what we did here. We had our initial velocity data, right? All of these trials of initial velocity data. And well, let me just kind of highlight here. When we had this raw data, we took this raw data, we plotted concentration versus time. The slope of this line gave us a data point that is one of our initial velocity data points, right? So let's see if I can find where that point is. It was at 5554. So that's that data point right there. And then we did 3 of those experiments so that we could average this, okay? So that's what all of this is. And then we sort of were talking about how you take your data that we get from the spectrophotometer and open it up in Excel and fit it to a straight line. And we take that slope, and that slope is our initial reaction velocity. And so this looks similar. This is that table that we just had that has trial 1, 2, and 3, our average and standard deviation. And then that first plot that we did looks like this, right? Looks pretty much just like this. And then we made our Lineweaver-Burke plot. So I want to hold on this slide here just for a second, just to kind of highlight and have you guys look at and see my data looks kind of like this, right? If I flip back to my Lineweaver-Burke analysis, I kind of have something where these three lines all seem to be going back to the same point here on my x-axis, right? So does anybody remember what kind of inhibition is that? That's
Have the same
competitive.
y-intercept.
Yep, they're going to have the same y-intercept, which means that y-intercept is going to tell us they have the same Vmax. So part of the reason why I'm going through this kinetics analysis with you too is that case study that you're going to have to do as part of your take-home part for lecture for the kinetics kind of module. You're going to be working with a group, but you're going to have to analyze data like this. Not this much data. You'll have a much smaller set of data. But you're going to be looking at plots like this. Okay? So I'm going to kind of walk through here what the next part is that we're doing. So if we note here, there's two pieces of information that are important that we can get from a Lineweaver-Burke plot. The y-intercept will tell us 1 over Vmax. The slope is essentially going to tell us Km, or a scaled up version of Km, and Vmax. So how we're going to walk through this last little piece here is we're going to walk through, and I think I have this here on this next page, how we determine these kinetic parameters. Okay, so using that first data set, we're going to determine Km and Vmax for LDH. We can use the y-intercept to give us Vmax, and then once we know Vmax, slope, even though it has two variables in it, really only has one that we're solving for, because we're going to solve for Km. Does that logic follow for everybody? Does that make sense? All right. So we've got slopes and y-intercepts on these lines. So if you flip to the last page that we have here, okay, what we're going to do here is we've got our 3 data series, and we're just going to transfer whatever the y-intercept was from those lines and the slope from those lines. Okay, so you might have to toggle back and forth between these worksheets here to get those pieces of data, but go ahead and find those pieces of data and put them in here. I can cheat because I've got them written down on another paper. Okay, so that data was just taken directly from our Lineweaver-Burke analyses plots, where we got these straight lines here. So I'm just going to look at you guys for a second. Give me a thumbs up if you've transferred all of that information. And if you need to, you can cheat from my stuff here to stop toggling back and forth between those two workbooks. So again, we're walking through kind of this logical progression of here's the data that we can easily get from a straight line, the slope and the y-intercept. And then we're going to go through how we translate that into kinetics parameters that are useful. We said that Vmax was equal to 1 over the y-intercept. So I'm going to say equals 1 over my y-intercept. That's going to give me Vmax. And then I'm just going to copy and paste that down. That one was pretty straightforward. I'm actually going to calculate an average and a standard deviation for this as well. Give me a thumbs up when you're done with that column's worth of data.
Dr. Parente,
Yes.
is your average Vmax just an average of those three
Yep.
Vmaxes in column D?
Yep.
Okay.
Yep. And the same thing for the
I
standard deviation.
I have a different number for the average.
Well, let's see. Do you have the same numbers
Not
for?
by. Yeah,
Let me
I have the same numbers there.
let me make sure that I didn't transpose and write a number incorrectly here.
It's not off by a lot either.
But it shouldn't be off by any. So that's why I'm baffled. That's odd. What is your number?
Mine is 1.10300000338.
Huh. Here, tell you what, I'm curious. Can you just share your screen for a second?
I can't because I'm on two different things.
Ah. Got it. All right, don't worry about it then. I don't know why that is. That's bizarre. But we'll just move on. All right. So
Okay.
hopefully it makes sense. If the slope is equal to Km over Vmax, if I want to solve for Km, it's slope times Vmax, right? That's just some simple algebra. So for this, I'm going to say equals my slope times the Vmax. And I'm going to copy that down. Now, I'm not going to do an average for this one because we would expect that these would change. Remember, when we think about what a competitive inhibitor does, a competitive inhibitor is going to increase Km. It makes it appear as though the substrate binds less tightly. We need more of that substrate to get to that 1/2 Vmax, right? So this is consistent with what we'd expect. Connor, question? I can't hear you. You're muted.
You said just to do C2 times D3, right?
Yep.
I got 17.91.
For this guy.
Yeah, and I have identical numbers for slope and Vmax. And I just did C2 times D3.
Oh, it's C2 times D2. Right? We have to take, and I think I said yes when you said it's C2 times D2. We have to keep the same row of data.
Oh. Yeah, I don't know why mine says D3. Okay, well that's the problem. Okay, thank you.
You're welcome. All right, so hopefully it makes sense to everybody. Our Km is going to increase, right? That's what we said happens with a competitive inhibitor, right? Even if we look back at this stuff right here, right? Even if we looked at, remember what Km is. Km is the concentration that we'd need to be at 1/2 Vmax. So if I say I want to be at 1/2 Vmax, here's Km when I have no inhibitor. When I have some inhibitor, my Km increases. When I have lots of inhibitor, it increases even more, right? So these sort of scaled up Km factors are what we're going to call Km apparent. That's what the Km appears to be when we have inhibitor there. Okay? So one of the things that I hope we can see here too from this plot is the slope of this line is alpha times Km over Vmax. Now, Km and Vmax are properties of that enzyme. They don't change. What we can do to have this change when we have inhibitor is we are going to have a scale-up factor. Remember, we described this scale-up factor is it's going to make Km appear larger because we're multiplying it by it. Alpha is always greater than or equal to 1. Okay? So the next thing that we're going to do is we're actually going to figure out, well, what's alpha? Okay? So see if this makes sense here. So again, the slope is really equal to alpha times Km over Vmax. And alpha times Km is what we call this Km apparent, what the Km appears to be when it's scaled up by the presence of the inhibitor. Okay? We can determine alpha using a ratio of Km values. Right? So let me come back to this plot and look here. The only difference, the slope of this line is Km over Vmax. The slope of this line is alpha times Km over Vmax. So the slope of this is twice because alpha is 2. So if I compare the slope of this line with the slope of this line, I can solve for what alpha is. Does that make sense to everybody? All right, so I'm going to come back to our plot here. Alpha is equal to the ratio of the apparent Km in the presence of inhibitor divided by the Km when there's no inhibitor. So I'm going to calculate it for the low inhibitor situation. That's going to be equal to the Km when I have the inhibitor divided by the Km when there's no inhibitor. Does that make sense to everybody? Now for this next guy, the alpha when I have a high inhibitor, that's going to be equal to the Km that's higher, that apparent Km in the presence of inhibitor, divided by the Km when there's no inhibitor. So that's that guy. So as we increase the concentration of inhibitor, we'd expect alpha to get bigger. Okay, so I'm going to flip back just for a second.
Dr. Parente, I have a quick
Yeah.
question.
Yeah.
Is that first alpha then with the 18.5, is that just 0?
It would actually be 1.
Oh.
Yep, because you take this 18.5 and you divide it by itself.
Oh, okay.
Right?
Thank you.
But so thinking about what alpha really is, right? I'm going to come back down here. If we think about what alpha really is, alpha is like, you can think about this as being the strength of our inhibitor. How much inhibition is that inhibitor going to do? If alpha is equal to 1, the inhibitor has no effect. So alpha is always greater than or equal to 1, and the bigger it is, the stronger the inhibitory effect. So remember we said there's 2 ways that you can have an inhibitor be really powerful. 2 ways that you can make alpha be much bigger than 1. You can have a high concentration of it, or you can have a very small Ki, meaning it binds really tightly. Everybody with me? So from a drug standpoint, if you were designing this molecule to be a drug that inhibited an enzyme, ideally you want to have it have a strong effect. You want alpha to be large without having a very high concentration, which means we want Ki to be really small. Does everybody follow that logic? So Ki is an important value to determine. That's the whole reason we're actually going through all of this math, is we want to calculate what Ki is. Okay? Now, this equation has 3 variables to it. It has alpha, it has Ki, which we're interested in, and has the inhibitor concentration. So basically it's saying if you can figure out what alpha is, and you know what your inhibitor concentration is, you can calculate Ki. Everybody following the thread there? Okay, so this is all kind of what's in this giant table that's here. We just calculated alpha. We figured out alpha by taking the ratio of the apparent Km in the presence of inhibitor dividing by the Km when there's no inhibitor there. And we did that for both the low inhibitor and the high inhibitor states. Now, I didn't tell you what it is, but this table tells us that we know what the concentration of the low inhibitor is and what the high inhibitor is. So now that I know my alpha and I know what my inhibitor concentration is, I can calculate Ki. So Ki is really just going to be doing this algebra here, right? I would take alpha and I'd subtract 1, and then I'd have inhibitor concentration divided by alpha minus 1. That's going to be our calculation here. Everybody follow that algebra? So let's go back to our worksheet here. Question.
I had a quick question.
Yeah.
So is Ki, is that a unitless kind of measure? Or is there units to it? Like, does it matter what concentration you put up as your inhibitor? Because I saw that was in millimolar. I was assume there would be
Yes.
an importance.
Yes. So then the units of your Ki would be in millimolar. Because alpha is unitless. So again, that's an important point to point out, that it just has to do with whatever the units of your Ki will be, whatever units you have for your concentration for your inhibitor. All right, so let's go back over here and let's finish out. We've only got a couple of columns left here. This is the inhibitor concentration, which I just told you what it was. It was 30, and then it was 90 millimolar. Okay, so here I can see Ki is going to be equal to my inhibitor concentration divided by my alpha minus 1. We just kind of went through, and the logic of that made sense to everybody. So this is going to be equal to my inhibitor concentration divided by alpha minus 1. Okay? Going to do the same thing for the second one. Inhibitor concentration divided by alpha minus 1.
Can you do all 4 of those again real quick?
So 30 and 90 were just the values. Let me go back to this spreadsheet. They were just the values of inhibitor concentration that were provided for you. Okay? So that's what these guys are. And let me just kind of walk through here. We just went through and we're comfortable with the algebra to solve this for Ki. Ki is going to be equal to the inhibitor concentration divided by alpha minus 1. I'm not seeing a big nod with that. Do you see the algebra, or do you want me to write it?
How did we get alpha?
Alpha we got as a ratio. So alpha here, we calculate alpha as a ratio between the Km that was larger when we had our inhibitor divided by the Km when there was no inhibitor. So essentially, it's just the ratio of the slopes of these two lines. Because in theory, if Vmax is the same, right? The slope of this green line is Km over Vmax. The slope of this line is alpha Km over Vmax. So if we take the ratio of those two, the Km's and the Vmax cancel, and I get what alpha is. Does that make sense? Okay. So to get, and this is just, you were good with this algebra, so Ki is going to be equal to my inhibitor concentration divided by the alpha that I just calculated minus 1. Good with that? Yes? All right, I'm going to do the same thing with this guy. Now, in theory, these two should be the same, but we've got experimental error here, okay? So this is equal to my inhibitor concentration divided by alpha minus 1. So in theory, you might do like a few more of these experiments, increasing your concentration of your alpha, and then you would have a bunch more data points that you might be able to average together to give you an average Ki. Questions?
So is Ki, is that your concentration you need for half of your enzyme to be bound to inhibitor? Is that kind of like the trend of that?
Yes. And I think we can use that language with a competitive inhibitor. I don't know if the language becomes different as we think about if this was an uncompetitive inhibitor, which would mean it actually doesn't affect the substrate binding to enzyme. If anything, the substrate binds more tightly with that uncompetitive inhibitor. But again, these values, the smaller these values are, the stronger that inhibitor is. And again, this was a situation where, we're in the millimolar range here. So, with this lab as it's designed, I can't choose a really good inhibitor because otherwise you won't get any data. Because when you add it in, it's just going to basically make it be a flat line. You won't see the chemistry happen because it's such a good inhibitor. So this is not actually drug level of inhibitor, but we can calculate what Ki is. All right, did I hurt your heads too much? I'm seeing some no's and some yeses. Okay, so look back at this, right? So this is all that you need to turn in. Essentially, this workbook is what you need to turn in for your post lab for the kinetics lab. Okay, I used to have people, and I'm just not going to have you guys do it this year, try to go find a literature value for lactate dehydrogenase for Km and Vmax and see how close we were. But don't worry about it. That was the only sort of post-lab thing to do here. But we're not going to do that. So just upload this workbook to Blackboard, and then we're done with that.
Parente,
Yes, Corinne.
we just upload it as is, like we don't have to add anything, or it's done.
No, as long as it's done. Now, Ashley, I don't know if you had a chance to go back and fix that one part, but if you didn't, just make sure you fix that one little part before you turn it in. But again, the deadline that I set for this is next week, Friday. So there's time to kind of finish that out. All right. So the next thing, and I'm fine. With this morning's group, we took like a little 15-minute bio break before we kind of delved into the next part. It's up to you guys if you want to take a little break. I'm seeing some head nods for yes. So tell you what, why don't we take a 10-minute break here? So we'll come back at 3:50, give you a chance to stretch your legs, use the facilities if you need to, grab something to drink, and we'll come back. I will plan on joining you guys a little after 3:50 then. All right?